So 5-2, we started this on Tuesday. We made it through all the explorations, correct?
Yeah.
Made it through exploration 1, exploration 2, and exploration 3, and that's where we stopped, right?
We got to the formula.
Yes, yes.
So we're going to copy it down.
Yep. Question.
Oh, no, it wasn't a question. It was just like a suggestion. Okay, so I tested in Miss Ingerly's class, and she had like these signs on her wall.
Mm-hmm.
It was like of like, you know, what we're doing now,
Mm-hmm.
and it like shows you how to do it.
Mm-hmm.
It was just a suggestion.
Oh, so you can buy me some signs for me to put up? Is that what you're suggesting? Oh, okay.
Maybe you could make the signs.
Here we go. Here's all our properties of our rational exponents. Don't fret over this. This is stuff you've seen before. These are the same properties that we used with our integer exponents. They're just the same properties that we can use for our rational exponents. So if you don't know what a rational number is, it's a number that can be written as a fraction. So this is just talking about exponents that can be fractions. Okay? I would maybe have it in my notes somewhere, or at least know where it is in my book, or at least make sure you know what each product or property is stating. Okay? So, the product of powers, if I've got two powers being multiplied by each other, I'll write it a little bigger, hopefully, if you can not see it very well. If I have a to the m times a to the n, remember, if we're multiplying two things that have the same base, we can add the exponents. You can go back into your book and look at it later. I'm trying to write it bigger for you guys so you can see it a little better over here to the left. This is what's right here. Okay? So if I'm multiplying two things that have the same base, I can add the exponents. If they don't have the same base, can I add the exponents?
No.
No, they have to have the same base. Power of a power, so a power raised to another power. Here we have a to the m raised to the n power. What I can do with those is I can multiply the exponents. So a to the m to the n would be a to the m times n. Power of a product. Got two things being multiplied together, raised to an exponent. Got a product raised to an exponent. I can just raise each part of that product to that exponent. So AB to the m power would be a to the m power times b to the m power. Negative exponent. Remember, if I have a negative exponent, to make it positive, I change its position in the fraction. So a to the negative m becomes 1 over a to the m. Zero exponent. Anything raised to the 0 power is 1, not 0. Anything raised to the 0 power, except for 0, is 1. If I have a quotient of powers, I've got a to the m over a to the n. If we're dividing something with the same base, I can subtract my exponents. So a to the m over a to the n becomes a to the m minus n. And then finally, the last one, the power of a quotient. We got two things being divided, raised to an exponent. I can raise my numerator to the exponent, as well as my denominator to the exponent. So a over b to the m power equals a to the m over b to the m. And there's some lovely examples on the right that use numbers if you'd like to see those. Those are also in your book. What page is that on? 248. So if you'd like to go back and look at this, this is on page 248, not 288. 248 in your book. So like I said, you should know these properties. You might want to have them written down. That may help you memorize them a little better. Are there any questions about any of our properties before we move on?
On the quotient of powers, what is that a to the m over what?
This is a to the m over a to the n equals a to the m minus n. If you notice on some of these, a cannot equal 0. That's just because if we have a fraction, we cannot have 0 in the denominator. Otherwise, it's undefined. So all the ones that are fractions say a does not equal 0, b does not equal 0. And then if I have a to the 0, I don't want a to be 0 either, because 0 to the 0 is not 1. We don't want 0 to the 0 power. Okay?
What does it say on our product is AB and has that m on that side?
Yeah, so ab to the m power equals a to the m, b to the m, as in McAllister. Any other questions on my properties of rational exponents? We good? Can I go ahead and move on? Okay, I'll give you a little more time. So once again, page 248, if you need to go back and look at that in your book. So here's some examples. Use the properties of rational exponents to simplify each expression. Letter A. I have 7 to the 1/4 times 7.5. I tried to make these bigger for you guys. Does that help? Can y'all see that a little better than the last page?
Yes.
Okay. No. Oh, I'm sorry. 7 to the 1/4 times 7 to the 1/2.
Are these notes on Canvas?
They will be.
Okay, because I didn't bring my box.
So what do I need to do here to help me simplify this expression?
You add the
Do you get the same denominator?
Well, what? Y'all haven't told me what I need to do first in order to get the same denominator. Or same. What do I need to do with my exponents?
plus.
Add them. There we go.
That's what I said.
I didn't hear you. Sorry.
Quadratic powers as the
They have the same base, right? So we're multiplying with the same base. I can just add my exponents. So yeah, we're adding 1 over 4 plus 1/2. You guys said we needed the same denominator, right? You are correct. You need a common denominator when adding or subtracting fractions. What would be a good common denominator here? 4. Luckily, this one's already 4 in the denominator, so just still 1/4. Made that one excessively big. How do I get the numerator of my second fraction? Multiply by 2. I multiplied my denominator by 2 to get to 4. Whatever I do the bottom, I have to do the top. So what's 1 times 2? 2. What's 1/4 plus 2/4?
3/4.
So I get 7 to the 3/4. And if it tells me to simplify it, I could leave it like that. I could rewrite it as the 4th root of 7 cubed if I wanted to. Or if the problem is asking you to write it in decimal form, you can just type it in your calculator and get it to the nearest whatever it's wanting. Okay? Questions on A? Not too bad, right? Letter B. I have 6 to the 1/2 times 4 to the 1/3. All of that raised to the second power. What do I need to do here? This is that power of a product property. So I'm multiplying all my exponents inside the parentheses by the exponent on the outside of the parentheses. So I get 6 to the what? What's 1/2 times 2? Times 4 to the what? It's 1/3 times 2. 2/3. What else can I do now? Add what? Add the exponents. Everyone agree with that? So I'm adding 1 and 2/3. Is that correct or no? Not quite. Why can we not add the exponents? Because we cannot add them. They don't have the same base. Right? Remember, I have to have the same base in order to be able to add the exponents. Right? So, I can just leave it like this because this is my expression simplified. Or, if it wanted a more specific answer, you could type it in your calculator, give a decimal form of the answer. Okay? Questions on B? Can I erase A and B to give myself some room for C? Is this making sense? How do I handle C? Multiply all my exponents inside the parentheses by the exponent on the outside. So what's 5 times negative 1/5? Negative 1. And I get the same exponent for 3. Do I want negative exponents? No. How do I handle negative exponents?
You have to put them on the bottom. Change the position.
There you go. Thank you for not saying flip the fraction. Thank you.
Yeah.
I change its position in the fraction. So this is technically over 1 and over 1. So the 4 to the negative 1 is coming downstairs, and that 1's becoming positive. So I get 1 over 4. Same thing with the 3. Bring it to my denominator. Where can I go from here?
Common denominator.
Do I need a common denominator when I'm multiplying fractions? I don't, do I? Am I done or do I keep going? Keep going. What do I need to do, Isaac?
You need to multiply.
Multiply. How do I multiply fractions? Across. So what do you think my answer is?
1 over 12.
You're right. Here's my answer. 1 over 12. 1 times 1 gives me 1. 4 times 3 gives me 12. Questions on C? Letter D. 5 divided by 5 to the 1/3. Someone raise your hand and help me out on this one. It is the quotient of powers. So what do I need to do? Subtract the exponents. But what's the exponent in the numerator? It is just 1. So I get 5 to the what minus what? Very good. We always do top exponent minus bottom exponent. We're able to do this because they have the same base. They both have a base of 5. So I have a 1 over 1 minus 1 over 3. What's a good common denominator? 3. What's my numerator on my first one? 3. What's 3/3 minus 1/3? So I get 5 to the 2/3. Questions on D?
How did you get 3 over 3?
So, we got a common denominator of 3, right? What did I do to 1 to get to 3? Multiply by 3. Whatever I do to the bottom, I have to do to the top.
Okay.
Got it? Questions on D? Can I erase all this work for E? Huh?
No.
Can I erase C? Okay, no one answered, so I'm going to do it. You're good now? Okay, letter E. Got 42 to the 1/3 divided by 6 to the 1/3. All of that squared. What do I need to do here?
We have to distribute the two first.
All the exponents inside the parentheses get multiplied by the exponent on the outside of the parentheses. This is the power of a quotient property. Got two things being divided, raised to a power. So multiplying the 2 times this 1/3 and by this 1/3. So what's 1/3 times 2? 2/3 and 2/3. Am I done there? You sure? Can I not rewrite this as a radical? And I would get a radical in the denominator, wouldn't I? Which I don't want. There's a simple fix to this. It's kind of going backwards from one of our properties, though.
That one.
It's the same property we just used. It's going backwards from that, though. The quotient, power of a quotient property. Think of going backwards from that.
So we just
Undistribute.
Undistribute. Okay. So what are you thinking? You're on the right track.
Divide by 2/3.
Not divide by 2/3. Kind of undistributing the 2/3, though. So what would that look like if I undistributed the 2/3 using
Would
that?
it just be outside the parentheses?
What would be outside the parentheses?
2/3.
2/3. What would be inside the parentheses?
42 over 6.
There you go.
Wow.
Good job, guys. I like that. Why does that help me in this case?
couldn't I can simplify it and
What's 42 divided by 6?
7.
So I just get 7 to the 2/3. Any questions there? Does that make sense why we did that?
Yes.
And does that make sense why this is not in simplest form right here? Okay. Any questions on any of our examples on example 1? Can I move on? Properties of radicals. Let A and B be real numbers, and let n be an integer greater than 1. So we have our product property of our radicals. If I have the nth root of A times B, then I can split them up into their own radicals. So it's the nth root of A times the nth root of B. And as you can see from our example, you can also work backwards from that property, just like we worked backwards on our previous example. So if you have two things being multiplied under their own radicals, as long as it's the same radical, I can write them under one radical together. And same thing with the quotient property. If I've got two things being divided under a radical, I can split them into their own radicals, so it's the nth root of a divided by the nth root of b. And we can also work backwards from this one and put them under the same radical. Any questions about this product property or quotient property of my radicals? We've dealt with these with square roots all last week. Dividing the radicals, right? We did a little bit of multiplying and a little bit of dividing. Today, we're going to go into higher roots than square roots. So we're going to get cube roots, fourth roots, fifth roots, so on and so forth. But any questions about the properties before we move on? Am I good to move on? Okay, I'll give you a little more time. Okay, let's go ahead and move on. Use the properties of radicals to simplify each expression. So, letter A, this is my product property of radicals. What does the product property of radicals tell me I can do on letter A?
Can split it.
Well, they're already split.
You can put those together.
I can put them together under one radical. Do I add them, multiply them, divide them?
Multiply.
Multiply them if I'm multiplying. So this becomes the cube root of 12 times 18. What is 12 times 18? 216. And now I can see if I can take the cube root of 216. What number times itself gives me 216?
Are we allowed to use calculators on this part?
Yeah.
Okay, cool.
What number do you think it is? What? 12? 12 times 12 is 144. 144, yeah, it's probably not going to work.
Would any of this be on the SAT?
6.
It might. It might.
6.
6. 6 times 6 is 36 times 6.
Or that, 216.
216. Questions on A?
So small. I just guessed.
Letter B. What does the quotient property of radicals tell me I can do on letter B?
You put those under the same, or, yeah.
Put 80 divided by 5 under the same radical, since they have the same root. So what is 80 divided by 5?
18. 15.
16. Close. And now I'm asking myself what number times itself times itself times itself gives me 16. 2. Questions on B? Not too bad? Product property of radicals, quotient property of radicals, pretty easy? Good. Can I move on? Yeah. Okay. So, last week we simplified square roots, correct? Now let's talk about simplifying just radicals in general. An expression involving a radical with index n is in simplest form when these three conditions are met. No radicands have perfect nth powers as factors other than 1. So what that's saying is, if it's a square root, there's no perfect squares that go into that number. If it's a cube root, there's no perfect cubes that go into that number for it to be in simplest form. So on and so forth. No radicands contain fractions. So I don't have anything like this going on for it to be in simplest form. I don't want a fraction under my radical. No radicals appear in the denominator of a fraction. We've already talked about that before. we've gotten rid of radicals in the denominator of fractions before, correct? You don't want a radical in the denominator of your fraction. Can my answer be a fraction?
Sure.
Yep, it can be a fraction. I just don't want a radical in the denominator, and I don't want a fraction under a radical. To meet the last two conditions, rationalize the denominator by multiplying the expression by an appropriate form of 1 that eliminates the radical from the denominator. We did that when we divided radicals last week and the beginning of this week. We multiply, if there was a square root in the denominator, we multiplied top and bottom by that same square root, correct? So we want all our radicals to be in simplest form. Give you a little bit of time to write this. For time's sake, we do need to go ahead and move on. We got one more thing to get through after this one. So let's look at some examples real quick. Write each expression in simplest form. I want to simplify the cube root of 135. So do you think my list of perfect squares is going to help me at all on this one?
No.
No. What do I need a list of?
Perfect cube.
Perfect cubes. So what's 1 cubed? Well, I guess I don't need that one because I want other stuff other than 1. What's 2 cubed? 8. 3 cubed? 27. 4 cubed?
48.
64. 5 cubed? 125. So on and so forth. So I'm trying to find the biggest perfect cube that goes into 135. So I can simplify this radical.
27.
The biggest perfect cube that goes into 135 is 27. 27 times what? 5. 27 times 5 gives me 135. How does that help me?
Now we can solve.
Simplify. How does this help me simplify? What can I take the cube root of that's under that radical now? 27. What's the cube root of 27? 3. So I pull that 3 out. Can I take the cube root of 5? No, so it stays under my cube root. That is now simplified. So very similar to simplifying square roots. Instead of using our perfect squares, we're using our perfect cubes. If this was a 4th root, I'd be finding my perfect 4s. 5th root, perfect 5s. 6th root, perfect 6s, so on and so forth. Does that make sense? Can I erase A and move to B? Fifth root of 7 over 5th root of 8. As this is right now, is it in simplest form?
No,
Why not?
there's a radical.
I have a radical in the denominator of my fraction. So how am I supposed to get rid of a radical in the denominator of the fraction?
Multiply it in the top.
Do what?
Multiply the bottom top
By what?
by the rest.
By what?
By 8.
5th root of 8. Let's try that out. Downstairs, what do I get? 5th root of what? What's 8 times 8? 64. Can I take the 5th root of 64?
Yeah.
What is it?
2.
2 times 2 is?
4.
4 times 2?
8.
8 times 2?
Oh.
16 times 2? 32. Can I take the 5th root of 64? I cannot. So, I've got to find something else to multiply by. Let's go ahead and list out our perfect 5s. What's 2 to the 5th power?
32.
32. Do what? 3 to the 5th power would give me 243. Thank you. 4 to the 5th power.
1024.
1024.
That's too much.
So,
Big number.
I need to multiply my denominator by something that'll give me one of these numbers. So what can I multiply both top and bottom by to get the denominator to one of these numbers? Not just 4. 5th root of 4. Does everyone see why we're doing the 5th root of 4? Because what does that give me in the denominator? 5th root of 32. Up top I get the 5th root of 28. Can I take the 5th root of 28? Can I simplify it? Do I have any perfect 5s that go into 28? No. So that is simplified. What's the 5th root of 32? 2. There's my answer. Does that make sense? It's a little easier with square roots because if you multiply it by itself, it gives you a perfect square. Here, if you multiply a 5th root by itself, you're not necessarily going to get a perfect 5 out of it. So you got to be a little more careful with what you're multiplying by here. Okay? Questions on example 3? Real quick, let's talk about conjugates. For a denominator that is a sum or difference involving square roots, multiply both the numerator and denominator by the conjugate of the denominator. The expressions a squared root of b plus c squared root of d and a squared root of b minus c squared root of d are conjugates of each other, where a, b, c, and d are rational numbers. So just know that you have to flip that sign for it to be a conjugate. If it starts off as 1 plus square root of 5, what's the conjugate of that? 1 minus square root of 5, because I flipped the sign. If it starts off as 1 minus square root of 5, the conjugate of that would be 1 plus square root of 5. Okay? So, you guys are going to be mad at me. I'm going to change the slide. I got to get to this example real quick before time is over. Usually, if we have a square root in the denominator, what would we multiply top and bottom by? In this case, square root of 3, right? So up top I'd get the square root of 3. Down here I have this expression that I would have to distribute the square root of 3 to. So I get 5 square root of 3 plus 3. Did I get rid of my square root? No. So this is why if I have an expression in the denominator where I'm adding or subtracting and it involves a radical, I have to use my conjugate. Because if I just multiply by the square root, it doesn't get rid of the square root. Because of that second part of the expression. So, what do I need to multiply top and bottom by here? What would be the conjugate of 5 plus square root of 3? 5 minus square root of 3. Does everyone see that? So up top, I get 5 minus square root of 3. Because anything times 1 is itself. And now downstairs I have to FOIL. I got to go back to Algebra 1 and FOIL. First, outer, inner, last. So my first terms. What's 5 times 5? 25. Outer terms. What's 5 times negative square root of 3?
5.
Negative 5 square root of 3, right? Square root of 3 times 5. Plus 5 square root of 3. Square root of 3 times the negative square root of 3. Negative what? Negative 3. So I'd get the negative square root of 9. Square root of 9 is 3. So negative 3. What happens right here in the middle with my two radicals? They cancel out. That is why I have to use the conjugate to multiply by when I have an expression like that in the denominator. What's 25 minus 3? 22. There would be my simplest form of this expression. Do the conjugates make sense? What does it make sense about it? We want to multiply by the opposite of it, the conjugate. So that way my radicals will cancel out. Because earlier I just multiplied by the radical. The radical didn't go away. And for it to be in simplest form, I don't want a radical in the denominator. So I got to do the conjugate so it does cancel out. Any questions before I end my recording and give you your assignment?